okay, we have a team that figured out a particular scheme. So the scheme they had is du dt approximately equal to, okay, they have a, b, and c. Let me plug in. Sure. So a is equal to 3.5. un plus b is minus 2, un minus 1, and minus 1.5, un minus 2. All right. So we had a scheme like that. And then the stability region they want me to compute is determined by a matrix. So their matrix is okay, let me see. So let me see. Amplification factor is, let me make it a 0, 1,000 matrix. And for I goes from 1 to 1,000, for j goes from 1 to 1,000. I want my amplification factor to be the max of the eigenvalues of this particular matrix. They have 2 divided by 3.5 minus lambda delta t ij. All right, 1.5, 3.5 minus lambda delta t ij, and 1, 0.
You didn't define lambda. Oh, you did previously.
Yeah. What? Oh, okay. So I think I need to have a. Am I also missing parentheses over here? Right. Okay. Did I have one more parenthesis than necessary? Is it? Okay. Yeah. Okay. Subscript. Oh, I didn't have the for loops. Okay. Okay, so I'm computing the amplification factor for all of these 1,000 by 1,000 entries. Okay, now it's done, and let me go to my command line history and figure, and just a copy and paste where I just have the amplification factor. Oh, I think I should have amp of I and j. Sorry. I'm just going to looping over. I want to overwrite the I and j entry of the matrix to be that. All right. So this is basically computing an array of 1,000 by 1,000 amplification factors. So actually I get a complex. So okay, so I think I also need to revise this, because when I'm computing the maximum, I don't know actually the behavior of taking a maximum over complex numbers, so I want to make sure I take the absolute value before I take the maximum. All right. Okay, so I think I already had a figure. I'm gonna go back to my command line history and do that. So this is what I got. All right, and let's see if I do the shading, color bar view 2, copy and paste. So this is what I got. All right, I got an implicit scheme with a stability region that seems to be a little bit smaller than that of backward Euler, but still very similar. All right. But one thing I notice here is that around the 0 point, I still get something like a semicircle. That seems to be a warning sign to me for a high order scheme. So usually when I see a more than first order scheme, the stability region around 0 point is usually a better approximation of the stability region of the real ODE. Which is what? Which is the entire left plane, right? So for all the lambdas whose real part is negative, the ODE is stable. So when you have a high order scheme, the stability region, especially when your delta t is small, should be very similar to the stability region of the real ODE. So it seems a warning sign to me. Here I see a significant curvature. Would you mind checking your Taylor series analysis to see if you messed up with any particular numbers? Okay. Usually, the most likely place to make an error in deriving or programming a high-order scheme is not something you can see immediately. It's something the code works, but it just doesn't have the order you want. I think that might be one of these cases. So anybody else got a scheme?
Second order?
I'm blanked.
What?
It says we're kind of completely blanked out of time until someone came back at 3 o'clock.
Oh,
this is plus, right?
So we're trying to find
so this is a
more accurate backwards Euler scheme.
All right.
So
Okay. So let me take this and
Taylor's expansion.
do this. So I got another scheme derived by Maya and Chloe. Their scheme is du dt. Let me change a different color. Their scheme is du dt approximately equal to u of, well, let me shift to an index because you are at n plus 1. un minus 4/3 of un minus 1 plus 1/3 of un minus 2 divided by actually 2/3 of delta t. All right. Okay. So let me factorize the 2/3 into the numerator. So I get this.
Did you check this? Yeah, I checked. Okay.
Minus 2
Those cancel.
plus half, right? That's right. Okay. So now okay. So what equation should I solve for the stability region? What matrix should I compute its eigenvalue for in the stability region?
What?
You got those values. Okay. Okay.
But there's a difference in the sign. So this one is plus half n minus 2, the other one is minus half n minus 2. That's all.
Sorry?
The difference between the two schemes is the minus and plus in the last two.
Well, no, we did the values and our first values were wrong. We
Okay.
made that calculation mistake.
So they have the same.
Yeah, so now you have the same values. Okay, that's a very good confirmation of what you did. Okay, and can one of you give me the matrix I should compute the eigenvalue for the stability region?